All right, hello. Welcome to the next video. We are diving into Unit 4 now that we've done a little bit of review on how to make ionic compound formulas. We are ready to really get into Unit 4. Hopefully you are watching this video prior to coming to class. We will not be watching videos in class very much. Most of the videos that I'm making for you are meant to be watched before you come to class. That way we can spend class time discussing it and actually working on the assignments that I have for you so that you don't have any homework, right? So that you have plenty of time to work on and finish those assignments in class. So, Unit 4 is all about chemical reactions. So today we're going to sort of introduce this topic by talking about the different types of chemical reactions. And you're also going to get a little bit of basic info about chemical reactions in general. So the objective for today is for you to be able to classify chemical reactions, classify them into one of these 5 types according to their reactants and their products. Okay, so you're going to be able to identify reactants and products in a chemical equation, and like I said, you're going to be able to identify the 5 different types of chemical reactions that we're going to discuss. Okay, so first of all, let's talk about what a chemical reaction is. A chemical reaction is some process that involves the rearrangement of the molecular or ionic structure of a substance. What that means is that atoms are moving around, okay? And if you're starting with a certain group of substances, maybe 2 or 3 different substances, if a chemical reaction takes place, then as the output of that chemical reaction, okay, after the reaction takes place, you are going to have new substances. The atoms involved in the molecules or in the compounds are going to be moving around and creating new substances, okay, different from what you started with, okay? Chemical reactions are chemical changes. So if you remember us talking about physical versus chemical changes way back earlier in the year, chemical changes are chemical reactions. Those 2 terms are synonymous. Physical changes, things like boiling and melting, those are not chemical reactions because the substances aren't changing into new things, right? When ice melts, it's going from solid to liquid. When water boils, it's going from liquid to gas. That's still just water, right? But in a chemical change or a chemical reaction, you're actually making new things, right? Think of iron on a car rusting, right? The iron is actually changing into a new thing called iron oxide. It reacts with oxygen in the air. That is a chemical change, okay? So, and then like I said before, when a chemical reaction takes place, at least one new substance is formed. This has to happen in order for it to be a chemical reaction. Okay, now when we write chemical reactions down on paper, we're going to use what is called a chemical equation. Okay, and it's kind of like a math equation, all right? It's a symbolic representation of the reaction using symbols and formulas to indicate the reactants and products of the reaction. So here's an example. We would do this in class if we were, actually in the classroom. If and when we come back to the classroom, we will definitely be doing lots of reaction demos in class. So this is hydrogen chloride, or really hydrochloric acid, plus sodium hydroxide, 2 solutions that are in liquid form. You mix them together, they're going to react with each other to form salt, sodium chloride, and water. Okay, this is the word equation. Okay, the compound names written out by in English. Then you have the chemical equation, which is written with formulas. Okay, so HCl plus NaOH makes NaCl and H2O. The left side of this equation, these are your reactants. The right side, these are your products. Okay, this arrow represents the reaction. Okay, the reaction taking place. All right, so things always move from left to right. And you'll notice that on the right side, we have new, different chemicals than when we started. And that's how we know that it's a chemical reaction. Okay, so there are 5 types of chemical reactions that we are going to talk about in this class. In reality, there are many more than 5 different classifications, but we're going to keep it simple for right now and only talk about 5 different types. Okay? Each type has a generic form, has a generic equation, which can help you identify, if you have a certain reaction, it'll help you identify which of these 5 types it is. So, the first type of reaction is called a synthesis reaction. This is where you have two or more separate chemicals that combine together into a single product. Okay, so you have two or more reactants that combine together into a single product. An example of this would be magnesium metal plus oxygen gas, making magnesium oxide. You can take little strips of magnesium metal, light them on fire, they will combust with oxygen in the air to make magnesium oxide, which is kind of like a white chalky substance. This is one that we will do in person if and when we come back into the building. The second type of reaction is the opposite of a synthesis reaction. It is called a decomposition reaction. This is where you take a single reactant and it's going to break down into two or more products. Okay, so it's literally the opposite of this, right? If you take this equation and flip it around, then you end up with this, right? So an example of this is hydrogen peroxide breaking down into water and oxygen gas. Okay, hydrogen peroxide usually comes in a black or brown bottle. And the reason that they store it in black and brown bottles is because the decomposition of hydrogen peroxide will happen much faster if it is exposed to light. So that's why they keep it in a dark container so that this decomposition doesn't take place as quickly. So your hydrogen peroxide will actually last you, months, if not years, rather than, days. All right, next type is called a single replacement reaction. There's actually single and double replacement, okay, type 3 and type 4. These are pretty similar to one another. What happens here is you're going to have an element by itself plus a compound, so those are your two reactants. The element is going to come in and replace one of the elements in the compound. So A is going to replace B, okay, and so A is now in the compound with X, and B is by itself. Okay, so an example here, let's say we have aluminum and hydrochloric acid. The aluminum is going to replace the hydrogen, kicking the hydrogen out. So now we have aluminum chloride and hydrogen is by itself. What this would look like is you've got hydrogen chloride, hydrochloric acid, that's like going to be in a little container. You put pieces of aluminum metal in there or aluminum foil. It's going to fizz and bubble. The aluminum is replacing the hydrogen, and those bubbles that you're going to see are actually hydrogen gas that's being released. So this is an example of a single replacement reaction. Now, a double replacement reaction is very similar. The only difference is you're going to start and end with two compounds rather than an element in a compound. Okay, so you see the difference here? Element plus compound makes element plus compound. This is compound plus compound makes compound plus compound, but we're still going to have the replacement, the little switcheroo. A and B are going to swap places. So A starts with X, B starts with Y. A is going to replace B, so now A is with Y, and B is with X. Okay, so you can see here in this example, we've got potassium iodide. Potassium is going to replace the lead. Okay, and lead is going to end up with iodine, so you have lead iodide, and you have potassium with the nitrate here. Okay, this is another really cool looking reaction that we will do in person when we come back. All right, and then lastly, the fifth type. This one is the easiest to identify, in my opinion. These are called combustion reactions. Combustion means burning, okay, or like exploding. So what you need in a combustion reaction is you need some sort of fuel, okay? Fuel is usually some sort of hydrocarbon, something that has hydrogen and carbon in it, like methane. The fuel is going to burn with oxygen gas to make carbon dioxide and water. Okay, you'll notice that these are not placeholders, right? In all these other generic equations, I have things like A, B, X, and Y. Okay, in combustion reactions, I don't have placeholders because it's not a placeholder. Okay, you have to have oxygen, CO2, and H2O in order for this to be a combustion reaction. Okay, you have to consume oxygen and you have to produce carbon dioxide and water in order for it to be a combustion reaction. All right, the fuel is the only thing that's going to change. Okay, you can have lots of different potential fuels. You could have methane or ethane or propane or butane or lots of other different things. Okay, that could be your fuel. All right, so that is it for the content here in this video. Just to review, there are 5 types of reactions, and your job in the assignment today is going to be looking at lots of different reaction equations, lots of different chemical equations, and trying to figure out which of those 5 types that reaction is. And you're going to want to reference these 5 slides, okay, looking at these generic equations, trying to sort of match up the reaction equation that you're looking at with these generic equations that are listed on these 5 slides. Okay? We will talk about and begin your all's assignment together when I see you in class later this week. Thanks a lot for watching.